So, trigonometric values represented by letters. These questions pop up in most exam papers and most tests, and they always start with the same thing. They start by saying that a trig ratio of a numerical angle is equal to a variable, and then they ask you to express things in terms of that variable. So here's our first example. Given that cos 72, there we go, there's our numerical trig ratio in terms of a variable. It's equal to m. Express the following in terms of m, and then they've got three things that we want to express in terms of n. So what we need to do first is we're going to draw a sketch. So we're going to draw our Cartesian plane. We're going to put our 72 degrees because we know that 72 has to be in the first quadrant. And then we're going to go, we need x, y, and r when we have a diagram like that. Okay. Okay, so we don't have to guess where the angle is. We know that 72 degrees is in quadrant 1. So we draw in quadrant 1. Okay, so that's the first thing. And then we're looking for our x, our y, and our r. Okay, so look at your ratio that you've been given. We've been given cos of 72 is equal to m. And now I need to give it a denominator so that I have cos is cos x raised. So that is your x and that is your r. Okay, so I'm just going to turn over. We said that cos 72 is m over 1. Cos is x over r. So in my diagram, my x will be an m, and my r will be a 1. Okay, and then we use x squared plus y squared equals r squared, like we did in the beginning of the section. So x squared is m squared plus y squared is equal to 1 squared. So y squared is going to be 1 squared is 1 minus m squared. So y is going to be plus or minus a square root of 1 minus m squared. In quadrant 1, y is positive. Therefore, y is going to be 1 minus m squared. Okay, so we know x is an m, r is a 1, and y is the square root of 1 minus m squared. Let's just fix that up quickly. Okay, so those are exactly the same steps that we would use for trig on your Cartesian plane without a calculator. Where are you drawing? What is your x? What is your y? And what is your r? And now we answer the questions. Okay, so my first question was, find sine 252. And remember with trig, it's always reduce. We have to reduce to an acute angle. So we're going to identify which quadrant it's in. Sine 252 is in the third quadrant. So it's going to be 180 plus something. Okay, so this is going to be sine 180 plus, And 180 plus what gives you 252, and it's going to be 72. So now we're going to go, it's negative sine of 72, exactly like we're doing with the numerical examples. And we know that the sine of 72 sine is y over r, so it's going to be negative m over 1, which is negative m. Okay, just add a page here. Okay, B, let's do B and C so that we don't have to keep going backwards and forwards. Sine 18 and tan 72. Okay, and remember we said x was m, y is square root of 1 minus m squared, and r was 1. Those are the things that we've worked out. Okay, tan sine 18, well that's in the first quadrant, so it's already reduced. Okay, it's already in the first quadrant. So if I can't reduce it, and remember I'm looking for an angle of 72 because my question is all in terms of 72. This is not 72. So I can't use my diagram to help me replace the sine of 18 unless I can find a relationship between 18 and 72. And what do you know about 18 and 72? It's equal to 90. So I can use a co-ratio. So for the sine of 18, it's going to be equal to the cos of 72. Those are co-ratios. So I'm going to replace sine 18 with cos of 72. Now because I have a 72, I can use my diagram to replace these. So cos is x over r, and we know that x is an m and r is a 1, so my answer is going to be m. All right, what about the tan of 72? Well, at least I have a 72, which is what is in my diagram, and that's what I'm looking for. So I'm going to go, okay, well, tan is y over x. And sorry, I should have actually asked you, this is in quadrant 1, so I don't have to reduce it. It's already reduced. Tan is y over x. Y is a square root of 1 minus m squared. And x is equal to m. So we're just replacing. But with these, you must make sure you are replacing with the numerical value of the angle you have in the diagram. So I can't use 18 if my diagram says 72. You've got to have that angle that's in your diagram. Okay, so let's just try another one quickly. If sine 40 is equal to k, so there we have it again, a numerical sine, a numerical trig ratio in terms of a variable. So I don't even need to read the questions. What I need to do is I need to do a sketch. Okay, so sine of 40, it's in the first quadrant, 40 degrees. So we would go 40, and this would be x, y, and r. Okay, sine 40 is k over 1. Sine is y over, sine is y over r. So that means that k is a y. So I'm going to replace the y with a k. And my r again is a 1. Okay, so what am I trying to find? Well, we're using x squared plus y squared is r squared, like we did in the beginning. And we have that I'm looking for x. My y is a k. And my r happens to be a 1 again. So x squared is equal to x squared plus k squared is equal to 1 squared, which is 1. So then I'm going to subtract that k squared from both sides. So this will be minus k squared and minus k squared. And then I'm going to finish by square rooting. So x is going to be plus or minus the square root of 1 minus k squared. But in the first quadrant, x is positive. Therefore, it's going to be positive 1 minus k squared. All right, so what do we have? We have x is equal to positive 1 minus k squared, y is equal to k, and r is equal to 1. Okay, so let's just move those over. And now we can answer questions. All right, so the questions were, sine 320, sine 140. What angle was I working with? Well, let's just quickly remember. This was 40. This is 1 minus k squared. This was there's my 40 degrees that I'm working with. We've got 1 minus k squared for x, k for y, and 1 for r. Okay, so sine of 320, so we go through our steps again. Identify. So this is fourth quadrant. So it's going to be 360 minus something. So this is going to be the sine of 360 minus 20. Sorry, 360 minus 40 to give me 320. So that's going to be negative, because sine in the fourth quadrant is negative. Sine 40. Now I've got the right angle. Okay, it's got to be the angle in your diagram. So it's negative y over r, which is negative k over 1, which is negative k. Okay, sine 140, quadrant 2, so it's 180 minus, and it's 180 minus 40, so that's positive sine of 40. Again, angle in the diagram. So we're going to again go positive y over r, which is going to be k over 1, which is k. Okay, let's quickly write down the next ones. Cos 230, cos 40, and just let's quickly do the last one. Tan 220. Okay. All right, so first of all, we start by reducing quadrant 3, so it's 180 plus. Okay, so cos of 180 plus 50. Reduce it, negative cos 50. This is not the angle in your diagram. Your angle in your diagram is 40. But 40 plus 50 gives me 90. So I have to use a co-ratio. So the cos of 50 is the same as the sine of 40. So I'm going to replace this with negative sine 40, which is negative y over r, which is negative k over 1, which is negative k. All right, what about the next one? Cos of 40, well, that is the angle in the diagram. It's quadrant 1. This is the angle in the diagram. So I'm going to go cos is x over r. We said x was 1 minus k squared over r is 1, which is the square root of 1 minus k squared. And then finally, tan 220. We need to reduce it. Quadrant 3, so it's 180 plus. So it's going to be equal to tan of 180 plus 40, positive tan 40. This is angle in the diagram, so I can use my x, y, and r to replace it. So this is going to be positive tan your exterior y over x. All right, and if you look back, your y is going to be a k, and your x is going to be a 1 minus k squared. Okay, so just a reminder here for this, my x was 1 minus k squared, my r was 1, my y was a k, and my angle was 40 degrees that I was looking at. Okay, so each one works exactly the same. We need to start by drawing our diagram, finding our x, y, and r, and that's just making sure that you reduce, and that when you reduce, you're looking at an angle that's in your diagram before you start replacing.